At the end of the code, it doesn't require any semicolon to terminate. And then no need to declare types explicitly. Now Python data types overview. So Python has several built-in data types including int, float, string, str, string, boolean, and then list, tuple, set, and dictionary. Now we use type function to inspect, like type of 42, you get an answer, class integer. Now let's get back to our Visual Studio Code for a demo of these. Now back to our Python folder. So let's create a new file. I call this type test .py for Python, and then I just paste it from my clipboard, and here it is, Python type test .py. So you can see that class is int, class is float for 3.14, and class is string. Okay, so they belong to these classes. I mean, this data type, int, float, and string. So it's a very handy function, type function. All right, now let's get back to our slideshow. So let's see C# versus Python type comparisons. Okay. Now here there is a table. So data type C# and Python, 2 columns, and then there are all of these. I mean, important data type. Comparison for comparison 6. Integer is written as int in C#. Python is also int. Floating point is written as double or float, and for Python it's just float. And string is written as full string. And str for Python, boolean is bool, both, and object is object any. Now this is a new term for C# developers, object any. So what does that object any means? Okay, it usually refers to the fact that object is the topmost base class for all classes in Python, and any, it can represent any type. Okay, any can represent any type because all types inherit from object. For example, if you see something like isinstance within bracket, circular bracket 42 comma object is true even though it's an integer. Okay, even though 42 is an integer. Now, so if a function accepts a parameter of type object, like type object, it can accept any data type. And in C#, object is the base type of all class, also system.object, and used for general type hints based on base of all types. So in Python, object is shorthand for accept anything, and that's why in the notes it is any, because everything is an object. Okay, now let's see some type conversion examples. So we have in Python x equals to integer, this conversion of a string 5 into integer, and conversion of a string within double quotes, that is 3.14. This is also a string because anything within double quotes, like in C#, it is also string in Python. So you're converting this string 3.14 into float and storing it in while. And name string. So you're converting the number 100 into string and storing it in name. And similarly in C# we have got convert dot to integer in 32 of string 5, and it will be stored in the integer 5. And similarly convert to double 3.14 will store the value as a double in y. Okay. So now implicit typing and dynamic behavior. So Python allows variables reassignment to different types. For example, if x is 10, then somewhere down the line in the code snippet, x could be reassigned as now a string. And C# requires type consistency or use var plus dynamic, var or dynamic. And you use dynamic or var, and the type safety is still enforced during runtime for var. And then let's see a type conversion example. This is the same example that I just showed. So print text. Okay, so let me run this. This is Python typecon.py. So you can see it is this 5, 3.14 and 100. Okay, so these are all strings which have been converted to integer, float, and then the number 100 to string. Right. Now there is another you can say function, not method. Both type we have seen to type check the type of a variable in Python, and isinstance is also used, and these both are used to inspect types in Python, but they have different purposes and behavior. Now the key differences are function, type, object. This returns the exact type of the object. So type of 42 tells you this is integer, and it's strict no inheritance support, but is instance, this function has got inheritance support, that is object of type. It takes two parameters, object and type, and checks if object is of given type or subclass or not. For example, if you check for isinstance 42 int, it returns a true, and it supports inheritance preferred for checks. Okay, so we can check this also quickly. So I added this line, print within bracket isinstance 42 comma int, so it returned true. That's what we expected. So let's come to this slide. So we have done this. Key differences: it supports inheritance preferred for checks, and type function, it returns the exact type of the object, and it doesn't support inheritance. So finally, what is the best practice between these two? Use isinstance for most real world type checks in Python, and it supports both inheritance and is more robust in data science workflows. So as summary and practice, Python is dynamically typed, C# is statically typed. Now you must practice creating and converting variables in both, and use type and isinstance for inspections, and try reassign different types to the same variable in Python. Okay. As a C#.NET developer, you'd likely very familiar with string interpolation, a powerful way to embed expressions directly into your strings. So, okay, so let's see. Now, string formatting is essential in both C# and Python. Now we've got a C# example, and I'm going to show you everything in Visual Studio Code in action. So var name equals world, var messages. This is the string interpolation. For those of you who have come from C# and .NET background and trying to switch over to data science with Python, so this is very familiar to you, must be very familiar. So var message equals string $sign within double quotes, then hello, comma, within curly braces name, and then exclamation mark, and curly this double quotes close and semicolon, and then console.write line, this message. Okay, so Python equivalent will be name equals within double quotes, it could be anything, say data scientist, greeting. And now this F is just like your C# $sign for string interpolation. Here it is, F string, it's called F string, F, and within double quotes hello, and then hello is followed by again very similar this a pair of curly braces, and within that the name, this variable is declared, and then print greeting. So there is no semicolon, as you are already familiar with by now in Python. So this is this, and before we go to the next slide, I would like to show you how it works in Visual Studio Code. So let's make a move to switch over to Visual Studio Code now. So here is the code, and this is written in a C# script, because as I've introduced in the previous video, I now have .NET script installed globally, so I don't need to go for a console application to create in C# code to work. So it is just a C# working as a script with a CSX file. Now, if you haven't visited that video, so please go through the previous lecture on variables and data types in C# and Python, where I have introduced it. All right. So if you run this, it runs like this. So it's already there. .NET script and the name of that file, and then you get this answer, hello world. That's what you required. You expected, right? Now, next will be our C# interpolation refresher. But before that, let me tell you that in the world of data science with Python, you will constantly be working with strings, dynamical labels for plots, formatting output, or paths. Python offers a similar and powerful mechanism, which is what I have already told, F strings. Now, this lesson bridges your C# knowledge to Python's F strings, and we'll explore, as we have already started, we are going to explore further similarities, differences, and show why F strings are your go-to for string manipulation. So here is another example. Now int data points 15, double accuracy 0.9812, string report. This is the string interpolation in C#, dollar data points, and then colon, and then pair of curly braces data points, and accuracy is accuracy colon P2. 2 points of decimal. Those of you who have not been acquainted with this P2 is formatting this accuracy of this double to 2 places of decimal and console.writeLine report. All right. So let's see this in action again. This is this file, and this is also a CSX file. So let me run this. Then it gets executed. So data points is 15 and accuracy is 98.12%. Okay. So 0.9812 is interpreted as 98.12%. So this is percentage up to 2 places of decimal. All right. Now, prefix with F use, as I have just shown you, use a pair of curly braces for variables. Name data scientist, greet F hello, name print greeting. Now, this is quite simple. So I have also this on my machine on my Visual Studio Code ID. So because this is a Python file, I'll be writing Python, and the name of this file is python fstrings.py. So hello data scientist, you get the expected result. Now, expressions in F strings evaluate expressions directly inside the pair of curly braces. Import. Now, there is another example that I would like to show. Import NumPy as np predictions np.array is the array of predictions, probabilities 0.8, 0.9, and 0.75, and average is this F string average np.mean predictions. Okay, so and this NumPy, this is a Python library, and it has got a mean function which gives the mean of predictions. So let's run this and print the average. Okay, so we'll get back to the Visual Studio Code. So this is the one. Let me clear to get more space. Now, average prediction confidence 0.81666666. So many places of decimal. Okay, so np.mean. So this is the mean value of all the predictions. So formatting Python versus C#. As C#, this is a double value is 123.45678, and string output dollar within double quotes val F3, and Python it is the same equivalent of the above code. In C# val 123.45678, output F# val 0.3f is F3, and this is 0.3f print output. Let's see this in action also. So this is the resulting output of this file, C# script formatting test.C# CSX 123.457 up to after the 3 places of decimal. This F3 means that 123.457. Now we'll run this code formatting test.py. So I've got two codes. This is one code which is exactly equivalent to what I've written in C# here, and this is another thing, alternate code snippet for import pandas, a pandas library. Okay, so I'll run this one. So this code, which has got two code snippets, are both executed. Python formatting test.py. The first part output is 123.457. Okay, which was the same as this one. It's C# equivalent in string interpolation, and this is your F string. And this part, alternate code snippet, import pandas as PD, pandas library. So this panda has got a data frame function, and these are just like C# table. This model is one column, XGBoost is another column, and this light GBM. This model means actually these are the number of this is the column name is XGBoost and light GBM, and these are the accuracy of this two, XGBoost and light GBM, 0.923 and 0.931. And this part is actually printing. This is index is not required, so that is underscore and a row in those table for number of rows in this data frame dot iteration over all the rows, iterate over data frame rows as index and series. Okay, and this is print model. So model is XGBoost accuracy 92.30 and light GBM accuracy 93.10. So here you can see that formatting is such that 0.2 is percentage. So this means that you've got two places of decimal. After decimal, there it is up to two places it forms, and 0.923 is 92.3 and 0.931 is 93.1, rather 92.30 and 93.10. Now the last thing is about data frame output that we have already just seen, and the key differences. So F strings are readable, performant, and introduced in Python 3.6, evaluated at runtime. And these are the old styles for F strings, percentage formatting and dot format method. And from 3.8 plus version, we use equals for debug info, like learning rate is 0.01. So if you are issuing this statement printf learning rate, then this will be this is the debugging information. This is the debugging information. If you need to debug, then you put this equation sign, equal sign. So what are the conclusions and takeaways? Familiar syntax for C# devs using prefix plus this pair of angular circular braces allows inline expressions with rich formatting, and F strings are modern, performant, and readable and debug friendly with equal to syntax in Python 3.8 plus. We're going to dive into the fundamental building blocks of any data science applications, which is numbers and basic mathematical operations. For those of you who are coming from a C# or .NET background, you'll find some familiar concepts here, but also some interesting and convenient differences in how Python handles numbers. By the end of this section, you'll have a solid understanding of how to work with numerical data in Python. So let's get started. Now, as an introduction, Python handles numbers with simplicity and power, and we'll cover number types, math operations, conventions, and advanced math, as I just told. So let's switch over to the slides. Now, in Python, you don't need to explicitly declare a variable's data type. Python infers the type at the runtime, which we have already seen. Okay, like x equals 100 or double equals 3.14. And integers or int are whole numbers, unlike C#. Fixed size integers, int or log. A Python int can be of any size. And floating point numbers or floats are numbers with a decimal point, like double or float in C#, and complex numbers are, of course, having a real part and an imaginary part. 2 is a real part, and 5j is an imaginary part. Okay, so let's switch over to Visual Studio Code and do some examples. Now, the first thing is Python's numeric types. So I will load up this numeric types.py and run this. So what is this code snippet? It's an integer So it's of course Python file, so I have to write Python code because it will not take and compile C# code and vice versa. So integer x equals 100 and print, this is the f string which we have covered in the previous lecture. Value is within a pair of circular braces, that is this one only, and we'll see soon in this thing. When we run this file, so type is type of x, and similarly for float, which has got a different value, and print a value, and type of y, and similarly for z, we get the value of z and the type of z. So let's run this file, Python file. So Python numeric types.py. So as you expect, the value is 100, type is class integer, and second one is type class float, and third one is type class complex, and the values of course what these are. So what are the basic mathematics operations? Let's switch over to the slides once more. So this we have already covered, and number types x integer, y float, and z is a complex number. Now basic mathematics operations are again the same as we are familiar from our primary school days, addition, subtraction, multiplication, division, but there is a float division and a modulus division. So what are these? Float division is once you are dividing an integer by another integer, this gives you the whole number, like 4 divided by 3 is float division, will give you 1, and modulus, that is the remainder division, just like in C#, 4 divided by 3, again the remainder is 1. And exponential is something to the power something. Alright, we'll see this in operation in a second. So switching over to Visual Studio Code again. Now this one is basic arithmetic.py. This is the same code that I just showed on the slideshow, and we will run this code. So here you can see this is actually, this is the one, a plus b 13, a divided by 3.33. This is the expected, this is the actual answer that we are going to get, but let's see. A float division 3 is 3, okay, is a whole number, and a asterisk b, a to the power b is 10 to the power 3, 10 into 10 into 10, that is 1000. So let's see all of these in action. Now this is the basic arithmetic. So again, 10 plus 3, 13, 10 divided by 3, 3.3333 is a long number of places after decimal, and 10 float division 3, that is 3, is a whole number part of it, and 10 to the power 3 is 1000. Alright, so far so good. So next is type conversion. So switching over to the slide, type conversion. Int will, when you are converting to int, it will truncate the decimal part, and it will operate on float, convert an integer to float, and this str will convert number to string. Let's see all this in action. So switching over to Visual Studio Code, this is the type conversion file. So my int 7, my float is converted to float, my integer, and let's see the value. Similarly, we've got another float 3.99, and another integer is converting that float to an integer with int operation, and putting the value in another int, and similarly to string, this my int, this is 7, and store it in number to string. So basically this is to convert it into float, convert it into integer to float to integer, and number to string. Alright, and then we'll actually run this file. So Python, this is type conversion. Py. Alright, that's what we were expecting. Value is 7, type is class float. This is value 3, type class integer. Alright, because we are converting it to integer. Finally, value is 7, type class equals string, because we are converting the number to a string. Okay, so Yeah, and then the next one will be an advanced math. Py, what we have here, type conversion is taken care of. So I've got this sqrt, square root of for power, ceiling and floor, and pi, and round is built in. So these are the built-in functions in Python. So we'll see that these functions also in action. So for that we'll use advanced maths.py. So we'll have to import the math module and then print the square root of 16 is math.square root of 16. What will you expect over here? We'll just, before seeing the result by running the file, it's better to guess what the value will be. So I will say square root of 16 is 4. And math.py, the value of pi, this I will not guess because I don't remember 3.14. After that, how many places of decimal is going to fish out. That doesn't matter. So, and math.pop 3 and 4. So 3 to the power 4, 3 into 3 into 3 into 3. That is 81. And math.ceiling, ceiling is on top, 2.1, that is should give 2. And math.floor 2.9, this should give 3. And rounding 3.14159 to 2 decimal places should give me 3.14. So let's see all of these in operation again. So Python, this one is advanced math.py. Yuppie, the square root of 16 is 4. The value of pi is approximately 3.14159 and so on and so forth. And 3 to the power 4 is 81. Okay. 3 to the power 4. 3 into 3 into 3 into 3, 8, 81. And ceiling of 2.1 is 3. Ceiling of 2.1, yeah, it's on top. I mean, it is to the next whole number, it is ceiling is on top. It's more than 2.1, so it will be 3. And floor of 2.9 is 2. This is on the bottom. You can think ceiling is on top, should be 1 above this, and floor is rounded to 2.9 to 2. And rounding 3.14159 to 2 places of decimal is 3.1. So that is what we expected. Right. Now there is a small interactive quiz. So this we have already gone through. What are the results of x divided by y and x // y? This is floor division, and x percentage y and y to the power 3. Alright. Switching back over to the quiz, this is the quiz.py. X equals 9, y equals 4. Predict the output of these 4 lines before actually running this. So I would think x, okay, I will leave it to you to run first, imagine or guess the answer before running it. I'll leave it to you to practice. But if you want the answer, I'll quickly run this. But you must try to understand how it works. Okay. So 2.25, 2, 1, and this. So finally, what are the key takeaways? So let's go back to our slide. These are the answers. What are the key takeaways? Python's numeric type, that is int and float, are key for data science. And Python supports dynamic typing. Division is different. So one / always returns float. Use this is float division for integer division, and use int, float, and string to cast types. And for advanced calculations and constants like pi, use the math module. We are diving into one of the most fundamental building blocks of programming, Booleans and conditional statements. Now, if you are coming from a C# or .NET background, which I'm sure most of you would be, you are already a pro at this. You live and breathe if statements, curly braces, and Boolean logic. You know that decision making is everything, whether it is checking if a user is authenticated, validating input, or directing application flow. In data science, this same logic is the key to unlocking insights. How do you filter a dataset for transactions over $1,000? Like, how do we create a new category of customers based on their age? The answer is conditional logic. So Python makes it incredibly intuitive and readable using simple if, elif, elif for else if, and else statement. Let's see how it compares to what we already know from C#. So just like C#, Python has a Boolean data type that can be one of two values, true or false. So in Python, the T and F are always uppercase, true and false, as opposed to C# lowercase, true and false. Okay, so let's see an example by going to our Visual Studio Code. So, I'm reflecting what I'm saying orally on this slideshow. These are the bulleted points. So in Python, conditionals are written using if, elif, and else. And no curly braces, remember, use only indentation. So I have opened the Booleans and conditional folder, another dedicated folder that I have created for this lesson only. And let's create a file. A new file, a Python file. So we'll test Boolean test .py. Don't forget to put the py extension. Okay, so this is a Python file. So in this example, I will be checking the type. Okay, so what is the type of true and false? So I'll just paste over this code, save it, and bring back our good old terminal window. Control with backtick, control plus backtick combination. I've got this terminal window which is just opening right into this folder, and then I give it a command. So what is the command? If you remember from the last few lectures, it is starts with Python. If you guessed Python, then you guessed correctly. So Python. Now this is the file name, Boolean test.py. See, class bool. Alright. Now, as I was telling that Python, the capitalization, true and false are always uppercase. So let's try with lowercase, just for the sake of it, just for an experimentation. True. So it doesn't allow you to compile true. Any true is not defined. Okay. And similarly, false will not be defined. So you cannot do it. Now let's go over to our slideshow. What next? So this slide is about Python's bool, a familiar friend. The values true and false in uppercase is Python's way of looking at the things. Unlike the C# where the Boolean value could be true or false, but in lowercase. Alright, so let's go for an example by looking at C# code. Now this is an example on Boolean test.py, which is prepared. Now Python Boolean test.py. So class is bool, and both for true and false both have this class bool. They belong to Boolean class. Alright. So Python type class bool. Okay. And there is another Truthy and Falsy concept. Truthy is non-empty, non-zero, and non-null. And Falsy is 0, 0.0, empty string, empty set, empty list, and none. There is a core concept in Python that feels a bit different from C#. Alright. So it's not just false that is considered falsy in a conditional check. Several other values are also treated false by default. Those values that are treated false are this number 0, 0.0, an empty string, an empty collection like a list, and empty dictionary or none. Everything else is considered truthy. This allows for clean and Pythonic checks. For example, to check a list that has data in it, you don't need to check its count. You just check the list itself. So let's go back to our Visual Studio Code and look at this list check. Alright. It's a very easy snippet to understand. Data points is empty list, and if data points, then print processing data. If it is not empty, then else no data to process. So to run this, no data to process because it's an empty list. Okay, this is a pair of square brackets is an empty list. Okay, empty square brackets, empty list. Now is the turn of conditional statements: if, elif, and else. Okay, so Python uses indentation instead of braces. Elif is Python's else if corresponding in C#, and we'll see an example of an edge category check. Flipping over to Visual Studio Code, I've got these two snippets, age category.cs and age category.py. Now, at this moment, it will be good to remind you, if I haven't told you earlier, that you can test the C# script with the C# extension or CSX extension. Both will work. Okay. So if you write age category.cs and if you run this into age 15, 25, age is less than 13, console.writeLine child, if less than 18, console.writeLine teen, else adult. Okay, so this will be an adult. It will write on the console adult. So let's write the .NET script for this. The .NET script, this is age category test. Okay. Rather age category. .cs. So CS file extension is also equally valid for .NET script to run. This is easier to remember. So henceforth I will be using CS rather than CSX. It takes a little bit of time. Adult, that's what we expect because the age is 25. And if we run the Python, the correct script is a Python script. So adult. Okay. So there we go. Python and C# corresponding C# version print the same. Adult. Next we come to the comparison and logical operators. So there's the next slideshow. Now equals is equal to, not equals not equal to, greater than and less than, greater than and less than. And these are the comparison operators in Python. See the absolute similarity with the C# comparison operator, greater than equal to, greater than, less than equal to, and logical operators in C# and both true, and or is either of them true, this is the or symbol, and not is invert of Boolean, that is not operator. Okay. Now before using this user authentication example, putting it all together, we'll go back to our previous slide and we'll apply this knowledge of logical operators in Python and C# to a data-centric example. Now imagine we are filtering a list of candidates based on their experience and skill. So here I will create another file, Python file. This I can call anything data-centric. Say for example data-centric test or data-centric example .py. Alright, and to this Python file I use this code. So years of experience is file, no SQL true. Okay, this is a Boolean and this is an integer. If years of experience is greater than 3, now here it is 5 and no SQL, print candidate meets basic criteria. Okay, proceed to the interview, access granted, and else candidate doesn't meet basic criteria. So what do you expect here? Okay, so here I'll expect this to print out candidate meets basic criteria, proceed to interview. Alright, so let's make some space, clear out, and run this Python script, Python. candidates meets basic criteria, proceed to the interview. That's what we expected. Right? Now let's see the user authentication example, putting it all together. So let's see what it is. So we will compare input values using if, elif, else, and check both username and password, and return appropriate access messages. So let's visit our Visual Studio Code. Flip over to Visual Studio Code and write another piece of code. So I created another file in Python, user.authex.py, and I will paste the code that is with me. So again, it is a simple script. Input user. So input type is asked, enter username, and then input another input pass. So enter the password. The user, these are the user, questions to the user. Enter username, enter password. If input user equals the username, that is admin, and input password equals the password 1234, then login is successful. Else if incorrect password, else unknown user. Okay, so if input user equals the username and input password is not equal to the password, then obviously incorrect password. The third only option will be that the username is incorrect, that is unknown user. Alright, let's see how it works. So again, Python. Enter username. Okay, so I will enter username. The one is going to be admin and 1234. Login successful because username and password both match the condition. Now if I run it again to test the other values, so username, say admin again, and password incorrect password, and the third case is unidentified user unknown. So again, if you run it, enter username, not admin, admin. Intentionally spelled it wrong. Enter password. Password is whatever, it doesn't matter because the user is not known. Correct or incorrect password doesn't matter. So if I give you the correct password, still unknown user. Alright, that's what we expected. Now let's wrap it up all together. Okay, so Boolean, Python Booleans are true and false, uppercase, not lowercase, and truthy and falsy. Remember that 0, none, and empty collections, that is empty list or empty dictionary, that is a pair of curly braces. Empty curly braces are considered false. This is a powerful shortcut. Syntax logic is defined by indentation, not curly braces. Elif is direct equivalent of else if, and operators equals, not equals, and, or, not are there. Okay, in Python. Now the last slide is a mini challenge blood pressure classifier. Input is systolic blood pressure. Print normal less than 120, elevated 120 to 129, high is greater than or equal to 130. Okay, so your question is invalid if less than equal to 0, and this is very similar to the negative 0 positive challenge, but framed for a more data oriented scenario. Give it a try in your notebook. Okay, we will dive into a fundamental concept in Python, that is looping. For those with a background in languages like C# or .NET, you will find Python's approach to be refreshingly simple and elegant. Our focus will be on Pythonic way to write loops, the code that is clean, readable, and highly efficient. So why looping is essential? In any programming field, especially in data science, looping is a cornerstone. It's how we automate repetitive tasks like processing items in a collection, filtering data, or applying transformations to entire data sets. Efficient workflows are built on well-structured loops. Now, the Python for loop iterating with elegance. For loop is designed to iterate directly over the items of any iterable object. This could be a list, a tuple, a string, or even a dictionary. This design is a key distinction from C#, where you often have to manage an index variable manually. So no need for index tracking. Python's approach gives you direct access to each item, which results in cleaner and more intuitive code. So here is a basic syntax in action, iterating over a list. So it's a number list 10, 20, 30, 40, and for num in numbers, print. This is, we have already been introduced, string. This is f string as opposed to C# string interpolation, number colon within curly braces num. So it evaluates the number. So it's just like a for each loop, and it iterates over the numbers list and prints each number. So we'll see this in action, and we'll switch over to the Visual Studio Code. So I have opened my Visual Studio Code, and I have opened this folder which I specifically created for this lecture, looping with for and while, and I have got the list of all the code snippets that I will be using for this particular lecture. There are quite a few, so you'll be filled with a number of code snippets and walk through those code snippets and see it in action. So this is the first one, for loop list.py, in coordination with our this snippet of code. All right, it's the same code being worked upon in Visual Studio Code. So if I run this application, if I run this for loop list.py file, so this gives me, all right, the number is 10, the number is 20, the number is 30. So all these numbers are printed and they're individual lines, separate lines. All right. Now this for loop is designed to iterate directly over the items of any iterable object. This could be a list, a tuple, a string, or even a dictionary. So this one is a list, right? And then I will iterate over it. I'll show you the demo of iterating over a string. So for that, for loop strings, I will open it up. So for char in data, print char. All right. So I'll clear the stuff on my terminal window, and we'll get more space. So I will run this file again and explain it again in a second. So this is for loop string.py. So the easiest way, because I have tested them before, so all of these are being prompted to me. So I'll hit the right arrow button on my computer keyboard, and then bring it back, bring the cursor back, and then look for string. So I'll get the right file in front of me, Python for loop string.py, hit the right arrow key, and then run it. So DATA, that's what you expect, right? So its data is actually taken as an arrow. I mean, this string is taken as an array of characters, and these individual characters are printed on each on a different line. So that's how it works. Okay. Now, the next one is I will now get to the example of iterating over a dictionary's key value pairs. So it's in sync with our next loop, looping over strings and dicts. So this we have already seen in action. Now dictionary. So user ages is a actually dictionary of key value pairs. Alice 34, Bob 45, and Charlie 29. For name and age in user underscore ages dot items. So this dot items will bring you the key and value pair. So if you iterate like this, you can get the name as well as the age in an F string like such, when I demonstrate it. So this will be for loop dict.py. So if I run this, clear the space, okay, and then Python for loop string again, I put the, I click the right arrow key to get to this file, which is very similar to for loop. This one is for loop dict, okay, dict for dictionary. So dict.py, and then you hit the right arrow key on your keyboards and then run it. So that's what you get. Alice is 34 years old, Bob is 45, and Charlie is 29 years old. So it extracts the key and value from this dictionary pair of key value pair, a set of key value pair, or whatever you can say, a dictionary of key value pairs, and write it cleanly like such, right? Let's see what comes next in our slideshow. Using range for sequence. Now, range within a pair of circular braces n, it will iterate from 0, because it is 0 index based Python looping, 0 to n minus 1. Okay, 0 up to n minus 1. And then also range function takes start, stop, and step, and it is flexible for counters. And we'll run this application, run this code snippet first. For I in range 1, 10, 2, that means starting number is 1 and range is up to 10. In steps up to, we'll print it, and then there is a countdown. I mean, this is count up and this is count down for I in range. So it carries this operation also very easily, starting from 5, and end point is stop at 0 and step up -1. Okay, so we'll see this in action. Printf t minus I within curly braces. So it will all happen in a second. So I've got 3 range function examples. Range function dot py. So for I in range 5, print I. What do you expect over here? Just think for a second, and in the meantime I will just clear the space over here. So let's see this in action first, and then we'll dissect it. Python range. So range, I will just accept this and then come back and correct this range function f. So it comes to the correct file. Now, range function. So it types out, prints out on the screen 0, 1, 2, 3, 4, all are different range. This is pretty simple to understand. It starts from 0 and it will iterate up to the number 5 minus 1, that is 4, and that all the lines will be printed, all the characters, all the numbers, here it is number, will be printed on their own individual line. Alright, this is also a new stuff, because you are, instead of console.writeLine, it is just a print statement, will print it on its own individual lines. So let's clear it, and then let's see range odd numbers. Okay, so we'll get this range odd numbers.py. Now for a second, just think about it. For I in range 1, it starts from 1, and in the step of 2, then the next number should be 3, and then the next number is 5, and 7, then 9. Okay, so let's see it in action. Print I. Python, again, range odd numbers. Again, I start typing O, so odd numbers, and right arrow and hit enter. It will give me 1, 3, 5, 7, 9 as per my explanation just before. So the final one is range reverse count.py. And again, clear my stuff and run this. Python range reverse count. So range reverse count.py. Hit this. So this seems interesting. What does it suggest? It suggests the liftoff of a rocket or a spacecraft. T minus 5, T minus 4, T minus 3, T minus 2, and then T minus 1 after that is liftoff. Like, it is a countdown from the NASA, which launches a rocket, 5, 4, 3, 2, 1, then 0, and then liftoff. Okay. So it's a similar simulation of spacecraft launch or rocket launch through this Python range code looping. Now again, we get back to clearing this stuff, and what comes next, we will get through to our slideshow once more and see what comes next. Enumerate for index plus value. Okay, so what this is all about. Let's see what is enumeration. So clearing the stuff once more, and then what comes next. It's quite an involved lecture, as you can see, because of the nature of it. The while loop, which is giving you a flexible control. So count 0, and while count less than 5, printf count colon this count value of count within a pair of curly braces, and then this is the loop end condition. The test condition over here is count plus 1. Count is incremented by 1, so it will keep on. It starts from 0. It will increment every time by 1, and till it is less than 5, it will print on the terminal. All right. So let's see this in action on Visual Studio Code. So this is while test. This file is whiletest.py. So Python while to like whiletest.py. Simple enough. So I made a typo over here. So that's why I was doing it the other way. Whiletest by this is the wrong way. So it doesn't allow any typo, as you know from your C# and .NET background. Whiletest.py. Now I run it with the return arrow press. Count is 0, count is 1, count is 2, count is 3, and 4. Till this terminal statement, it will keep on printing count is and the value of this count. Right? This is quite simple for my C# friends and .NET. And then clear the stuff again. And then let me run another one. It's slightly more complicated. This is a task is set at a list of tasks, reply to emails, draft report, and call supplier. So while this condition is true, as long as the list is not empty, current task, this is a pop function. It removes the first item. So let's see what does it do. Remove and return item at index. Okay. So this is the 0th index. It starts moving from the 0th index, which is this reply to email, and then next item will be draft report, third item will be call supplier, and then it will print all tasks finished. Let's see it in action again. Python, it's not while test, this is while processing. While processing list .py. So this is our expected result, and we got our expectations fulfilled through the output. All tasks finished. And the next in line is this is done. Controlling loops with break and continue. Now what is break? For those of you who have come from a C# and .NET background, break and continue are quite familiar to you. Alright, it is similarly working on the Python. Now break exits the loop entirely, and continue skips the rest of the current iteration and moves to the next one. Alright, so let's see break and continue in action. So break example.py for I in range 10. If I equals 5, break. Immediately break. Also clear it and then run this one. Python break example. Break. I want to run break example first. Okay. Right arrow 0, 1, 2, 3, 4. As soon as it encounters 5, it breaks. Okay. It doesn't print 5. Okay, because this statement is ahead of print, so it prints up to 4 and then breaks. Right? And then equals 4 and is break specific now. Break specific.py. So now what is this break specific example? It is a product list of milk, eggs, food products, bread and cheese. So if product is bread, print found bread and then break. Okay. So checked milk, checked eggs, and then as soon as it finds the bread, so as soon as the product is equal to bread, it writes found bread. Okay. So initially it printed these two, checked milk and then checked eggs, and then it found bread because it break away after finding bread. Okay. But anyway, it encountered this print statement, so it wrote accordingly found bread. Okay. And then this is the continue example. Alright. let's see how it works. Python continue example.py. Okay. So 0, 1, 2, 0, 1, 3 and 4. Because as soon as it encounters 2, it skips that and moves to the next one. So 0, 1 and then 3, 4. 0, 1, 3, 4. So Python continue example.py will print out this output as we expect it to. Let's see what comes next. Pythonic looping best practices. We are coming to the end. Now, to make your code more efficient and readable, adhere to these Pythonic principles. Prefer direct iterations or use direct for loops or enumerate instead of managing indices manually. And use for loops for known collections when iterating over a finite collections like a list. A for loop is generally cleaner and safer than a while loop. And list comprehension. So whenever possible, creating lists based on existing iterables, use the list comprehensions. These are more concise and faster alternative to for loops. Okay. And now say, for example, it will find out the even numbers from this list of numbers 1, 2, 3, 4, 5, 6. So the list will have finally 2, 4 and 6, and the explanation is not difficult to understand. So even number is a list, empty list, and then numbers is another list of numbers, 1, 2, 3, 4, 5, 6, and for num in this list which has got these set of numbers, if num remainder division, num percentage 2 equals 0, there is no remainder, then to this even numbers which is an empty list. This is the basic why we made it an empty list. We are appending, because we are appending to this empty list this num. So, and then finally printing the even numbers, because now this even numbers is no more empty and it will contain only the even number, actual even number, which is extracted out of these 3 lines of code. So that's how we got it. But this is the same example, that I showed you earlier, but this is actually an even number test through enumerate function. So if we run this is a normal loop and this is enumerate loop. So I clear the stuff and then Python. So even, I'm giving them long names, which is actually a good practice, because even though it takes more effort to write it down, it gives you an idea of what this code snippet is all about. So see 2, 4, 6. So how it works, the numbers array already contains all the list of numbers like before. Let me take this out to loop normal loop number. Here we had a list of all the numbers in numbers, and if you go back, it's the same number list, but the even numbers was not initialized. Even number was not initialized like here, because even numbers will be evaluated directly with this list comprehension method. Num for num in numbers is this if num percentage 2 equals 0. So how the even numbers will be assigned to? With this statement. This is list comprehension, and then print the even numbers. Finally, it's just a print statement. So that is what I have already shown. This is very powerful, list comprehension, and when it is used once more for creating lists based on existing iterables. This is a more concise method and faster alternative to for loops. So finally, a quick recap, summary and challenge. So use for, while, range and enumerate effectively. That's what we have done in this, and follow Pythonic best practice, and there will be a challenge which will come in the exercise, which you can practice. All right, and we leave it at that. We are going to explore one of the most powerful concepts in Python, that is functions. So by the end of this session, you'll be able to define, call, and use functions to write clean, reusable, and efficient Python code, a crucial skill for any programmer. So now we'll explore how to define and call functions to make your code modular, reusable, and clean. Now, functions help break down complex code into manageable parts. They allow you to reuse logic and write more organized and maintainable programs. So, my learners and students that have come from the C# background will already have worked extensively with methods in C#. Methods and calling those methods. So functions are identical. Only the jargon technical name is different, and functions are prevalent in all of the languages as far as I'm aware. Like JavaScript also uses function, and any other programming languages, higher level languages, they use functions. All right, so what's next? Now, how do we define a function in Python? Here is how you define a function in Python using the def keyword. So we'll break it down into each part. The name, the function name, def is the keyword that is actually appended in front of the function name, and it has got the parameters which is optional. Okay, and this is a docstring, and I will tell you soon what is this. And this is functional logic after the docstring and a return value. Now we'll explain docstring in the next slide. So let's go to that next slide. What's the docstring? All right. Now a docstring is a string literal, and usually it is triple quoted, like triple quoted before the docstring string literal and after the string literal, and it appears right after the def line in a function, and it is used to describe what the function does. It's just like comment, another form of saying that it is defining what the function does. So def greet name greets the user by the name, and printf hello name. Now in this case, it these triple quotes before and after the docstring is the docstring. Okay, in between everything is the docstring. Now let's see. Def greet, print hello welcome, and we'll now move on to the Visual Studio Code. I'll flip over to the Visual Studio Code and run all the code one by one. So this is the Visual Studio Code. Now the first one is greet.py. So def greet is a def means again it is defining a function known as greet, and it's followed by a colon and a print statement, and is called to this function is calling greet. So we'll run this function. So what is the command? Python, again like the file name. So greet with param.py, that is another code snippet that will come next. So I'll just modify it to greet. Greet.py. Alright. So it returns hello welcome. That's what you expect, right? Next, we come to the topic of parameters versus arguments. What is a parameter? What is an argument? So when you define a function like such, this is whatever you are passing, this is a parameter. Now this is a function, but when it is called, this parameter assumes an argument, the name of an argument. So it's the same thing. The name is here per parameter, and when you call this function like greet user and pass Alice as the argument, okay, so the parameter turns into argument. All right, so we'll run that application also. So I have created this file greet with param.py. So here what I have just discussed on the slideshow, we have got this function def greet user passing name as a parameter. Here name is the parameter, but when I'm calling this function greet user, then the parameter takes the shape of an argument. So Python greet with param.py. So hello Alice. If you pass the name Bob or any other name, John, Smith, it will print out hello John, hello Smith, etc., etc. All right. So let's get back to our slideshow. So what comes next? Multiple and keyword arguments. Now next we have a function, say describe it, with pet name and animal type. And how we call it? One of the ways to call it is describe pet. I'm calling this function, and animal type equals within quotes dog, comma pet name equals bud. Alright, we'll also run this and explain. So I have got this function describe pet. It takes in two parameters, pet name and animal type, and prints I have an animal type within curly braces, pair of curly braces with f string, which we are now familiar with, and then the next line it prints my animal type's name is pet name.title, or even if you get rid of title it will still work. Okay, and then call this describe pet, animal type is dog, and pet name equals pi. So what do you expect as a C# programmers? I would expect this to print first. I have an animal type. Now animal type is dog, so I have a dog, it should print, and my animal type, that is dogs, my dog's name is pet name, that is buddy. Right, my dog's name is buddy in the second line. So let's run this to see it ourselves. Clear. Now Python, this is described. Okay, so I have a dog, my dog's name is buddy. That's what we expect, right? So what's next? This is taking care of this slide. Now the next slide is return value. This is the most important because I've created a few examples to show what is the return value, how the return values are used. Now def multiply AB, as you can expect, it returns the multiplication of two numbers, two parameters A and B, two numbers, and stores or reuses the result. So store the result in a variable. Now from multiply, okay, this is what we are going to run on Visual Studio Code. From multiply, import multiply. Multiply is the file name and this is the function name, and the result equals multiply, and passing these two arguments 5 and 3, and then result of this multiplication is the result. So let's run it. Now here is that function. This one is in another file, resulting variable.py. So from multiply, import multiply. So if you look into this, this is the file name, and then you are importing this function name from this file, import function, and result is calling this multiply function and passing 5 and 3 as arguments. So let's run it again. So Python result in variable.py. So the result of multiplication is 15. That's fine. Okay, so this is one of the ways, first way of using the result. The next way is you can save the value returned by function into a variable. That is what we have just seen, and use it later. So yeah, it's all done. And reuse the result within another expression. You can also use the result directly within another expression or pass it to another function. So we'll see that if multiply and you pass these two parameters arguments 5 greater than 0, print the result is greater than 20. Okay, so we have got this file. I'll run this code snippet, clear the stuff, and this one is use result. So Python use result within another expression. Okay, so the result is greater than 20. Of course, 5 into 5 is greater than 20. Right? It's pretty straightforward. And then I'll just close some of these files. It's all cluttered all over the place. Alright, I'll close this also. Now, what is the next slide? Now, we'll use the result passing the return value as an argument. So you can take the output of one function and use it in input to the another function. So we have got this again multiply function, and we've got created another square root function which takes a parameter or argument x and returns the x to the power 0.5. That is, this is to the power double asterisk x to the power 0.5, that is square rooting x, and pass the result of multiply to square root. So result in the result variable, I am calling the square root function and passing as an argument the result of the multiplication. Okay, so let's see this in action as well. It is this code snippet which I just discussed. So I'll just run this. Python use output as input. Okay, output of one function as input to the other. So result of passing the multiply output to square root input is 6. How it is 6? Because 4 into 9 is 36. That means the square root of 36 is 6. Then we have that reuse the result. Another way of reusing the result, nesting function calls. Okay, so we have got a addition function which returns the sum of two numbers, and then another function double n, which is actually it returns n multiplied by 2. If n is 5, 5 multiplied by 2, 10. Okay, so nesting pass the result of add to double. So print double, and in the double function I am calling the add function and passing 10 and 5. So 10 plus 5 is 15 multiplied by 2, output should be 30. So I will run this also. This is this nesting function .py. So Python nesting function .py and 10, because I am adding two numbers 2 and 3. 2 plus 3 5 multiplied by 2, because I am passing it to double function, which actually multiplies it by 2 and returns the output. So this is 10. All right. Now why this is useful? It reduces the need for temporary variables and makes the code more concise and helps when chaining transformations. Why this is useful? Why this using the return value in these few steps are useful? Because it reduces the need for temporary variables. You don't need to store it in temporary variables before using it these ways. Okay, and like in data processing pipeline, it helps. Okay, and then we have got a circle area challenge. Circle area challenge. Now we have got a challenge, in a small challenge in how to calculate the area of a circle through Python. So here it is a function. I've named it as calculate underscore circle underscore area, and I'm passing the radius. Now it should ideally return pi into radius square, but pi is not recognized by our Python, so I have to give it a value. Say 2 places of decimal. 3.14 is the easiest value to remember. However, this pi has got you can go to as many places of decimal as you'd like, but 3.414 is a good value to approximate. And for example, radius equals 5. So how do you calculate this? So circle area.py, return 3.14 times radius to the power 2. 3.14 is pi times radius to the power 2, pi r square. Okay, and area is calling this calculate circle area and passing the 5 value 5. And let's see what is the area of the circle. Calculate it this way. Clear the stuff and call Python circle area.py. So area of a circle with radius 5 is 78.5. Alright, so this is approximate value of a area of a circle. Now the last thing is a sort of bonus challenge, you can say. This is about the body mass index, BMI calculator. And what is the formula? Now this is the calculate BMI. It takes into parameters weight and height, and it returns weight divided by height square of the height. Okay, and then round it to 2 decimals. So let's run this also. Now this is bonus calculate BMI.py. Now example usage is, if you give a weight of say 75 kilograms and height of 1.76 meters, actually it's kilogram and meters, MK system. So just remember to put the height in meters. So this is actual formula, which is accepted worldwide for calculating the BMI of a person weighing this much kg and this much ton. Height underscore m, ton is this BMI. 2 places of decimals. So let's run this and see the fun. This one is known as bonus calculate BMI.py. And the BMI for a person weighing 75 kg and 1.76 tall is 24.21. So great, we have come to the end of the slideshow of today's lesson, and let us see a quick recap. So we have learned how to define and call functions, use parameters and return values, and apply them in real world example. All right, so that's the end of today's lecture. Thank you for attending it. In this part, we'll understand Python indentation and code blocks. So if you are coming from C# or another C style language, you are probably used to using curly braces to define blocks. In Python, white space is not just for readability, it's a syntax requirement. So in Python, indentation determines the structure of your program. Forgetting to indent or misaligning your indentation leads to syntax errors. It's not just about making code pretty, it's about making it run. So no curly braces like this square. This is curly braces in Python. This is a curly braces, set of curly braces, which all C# people are already accustomed to, but there is no such curly braces usage. So consistent indentation is mandatory. And let's see a Python versus C# example. Now this lecture, by its nature, it's just about indentation and how to write code in blocks in Python. So I'm not going to switch over to Visual Studio Code because there is not much to walk through rather than showing it on the slideshow. So this is C#, familiar C#, console.writeline, and this is a pair of curly braces, which is Python equivalent being if x greater than t, then this colon. Now after the colon, you have to give it a indenting. The proper way to indent, the standard practice is 4 white spaces to the right. Okay. Now a colon starts a block. Here you can see the colon starts the block and indentation defines its body. This makes Python code very readable but also strict about white space. So let's see the indentation rules. So just like I said, stick to 4 spaces per level of indentation. Now mixing tabs and spaces is a common source of errors. VS Code can be configured to insert spaces automatically, which helps maintain consistency, which I'll be covering in some detail through a resource on this lecture, and it will be taken briefly in one of the upcoming slides in this lecture. Now, indent after colons in if, for, while, and def. So let's see what are the common pitfalls. Now, this is a function, greet function, very simple, and the basic function print, and this will come as an indentation error because there is no indenting in the print statement, which the Python interpreter expects at least this block, and which is ideally to be defined as 4 white spaces to the right. And is this the fixed code which will be running all right without any indentation error. Now for nested block example, this is one. So this is check number x. If x greater than 0, print positive simply, else print non-positive. All right. So this is also an example of indentation for nested blocks. So it's all about structure through spacing. Now we come to the pro tip: configure your editor. Now I will not walk through all that is said, but it's very easy for you to follow. Once you look into the resources, the downloadable resource will be there attached to this lecture. That will give you all the steps. Use VS Code's Python extension, enable insert spaces instead of tabs, and use format on save or linting with flake8 or pilot. So to avoid indentation problems, we'll have to configure VS Code to insert spaces and auto format your code. Linting tools like flake8 help catch inconsistencies before runtime. So as a summary, Python uses indentation, and indentation is not optional in Python, it's mandatory. And you have to stay consistent, use the right tooling, and you will avoid one of the most common beginner mistakes. So use 4 spaces consistently, no tabs, and configure your editor to help you stay consistent. As a C# developer, switching to Python can feel unfamiliar, but it doesn't have to be. In this lecture, we'll walk through a compact C# versus Python syntax cheat sheet that maps what you already know in C# to its Python equivalent. Now let's start with the syntax basics. In C#, we wrap code blocks with curly braces and end statements with semicolons. Okay, like this. And we are wrapping this else statement or even the return statement with curly braces. In Python, there are no braces or semicolons. There are no semicolons. Okay, no braces like such. This one is different. This is for F string, which is a special case where you are still using the curly braces, but for all practical purposes, you are getting rid of the curly brace. Okay. Now, in Python, there are no braces or semicolons, indentations and colons. So, you do the heavy lifting by indentations and colons. Python reads more like pseudocode, which makes it incredibly readable once you get used to the format. So here is a list of int x equals 5, Python syntax equivalent is this, then print statement here and console.writeLine in C#, and it's an if statement. Here it is like this, return true if x equals 0, else false. Okay, and for statement, this is the for statement equivalent in Python syntax, and list and dictionary in both the languages. Okay. Now control structures. Control flows in Python like if, for, and while. If, for, and while. Now they map clearly or cleanly to C#, but with simpler syntax. So no parentheses required around conditions. No parentheses required around conditions. There is no parenthesis, and blocks are defined by indentation. The elif keyword in Python replaces else if in C#. Let's see functions and methods. Defining function in Python uses def keyword, as you are now aware. There is no need to specify return types or access modifier. Okay, so Python functions are inherently public and dynamic. If you are used to void in C#, just remember that a Python function without a return simply returns none. Here it returns a plus b, but if there is no return statement, it doesn't return anything. So there is no void, unlike here in C#. Okay, and then let's see collections. In Python, we work with lists, tuples, sets, and ticks. So this is my set, this is a list, and this is tuple, dictionary. Lists are the closest match to listy in C#. List of int as a list in C#. And dictionaries are similar to dictionary t key and t value. This is a type key and type value. Dictionary string and integer. And tick is the nearest to this dictionary. Indexing is zero based in both languages, but Python's slice syntax is powerful and compact. So I just said that Python slice syntax is powerful and compact. So what is a Python slice syntax? Let's revise it. I mean, I have done it in one of the lectures previously, but let's do it again. So Python slice, what is a slice syntax? The sequence is start, stop, and step. So where start is the index to start at, which is inclusive, and stop is the index to stop at, which is exclusive, and step is how many items to skip, optional. This step is optional. So why it's powerful? No need for loops. Nums is a list. This is Pythonic list, which has these elements 10, 20, 30, 40, 50. And if you print nums 1 to 4, it will print out 20, 30, 40. And how and why? Because it starts at index 0. The first index is 20. Okay. And it goes to the index 4, which is 50. But the last index is exclusive. Okay. It is exclusive. So it will print out 20, 30, 40. And it supports reverse and skipping. So nums, when you write like that, start and stop are not there, not specified. And the start, stop, and step -1. So if it is -1 step, then it starts from the reverse. So it starts from 50, then it skips one step, 40, then 30, then 20, then 10. Now it comes up to the first index or the 0th index because it actually because it is because stop equals none. Okay, slicing feels inclusive although it is exclusive. So index to start as is inclusive and index to stop at it is exclusive. It should include the start index and it should exclude the stop index. But sometimes there is an exception because it looks like that stop index is exclusive, but in this case it is even though it is exclusive, it feels inclusive because stop equals none. And here it ends at the last valid index due to stepping. So how it will be, this is start is not specified, so it is the first taken as the first element or the 0th index element, and this is the it is none and the step is 2. So it starts from 10, jumps by 2, skips the in between, so 10, 30 and 50. So it feels inclusive, although it is exclusive still. It always holds good. Okay, so let's run this example just as an exception. As I previously told that we are not going to run it on Visual Studio Code because there is hardly any coding to walk through, but I will quickly run this. So when I run this Python slice.py file, this is for slice examples. The nums is again the list of numbers 10, 20, 30, 40, 50, and then a number of printf statements, which I am going to quickly run through as an explanation. So when I run this, the first statement that I get is slice nums 1 to 4. 1 is the start, this is the stop, and there is no step here. So it gives you the answer 20, 30, 40, and original is this nums list. Okay, so this is clearly understood, I hope. 1 to 4 means the first number is the 1th index, that is 20, and then 4 is 50, but 50 is excluded, so 20, 30, 40, and step of 1. Okay, and then the second one is again 20, 30, 40, print nums 1 is to 4, and then print nums colon colon minus 1. So it is reverse, it starts from reverse. If it is step is minus 1, then it starts from the opposite order. It starts from 50 and it reduces by 10. In the next one is 40 and then 30, 20 to 10. It doesn't skip. Okay, and similarly, it starts with this is not specified. Starts is not specified. Stop is none, and the step of 2. So it starts with then 10, 30, and 50. By jumping one step in between. And this one is 20 and 40 because the starting point is 1 at this index 20, and then in step of 2, that is 40. That's it. And this is at index 4, which is 50, which is exclusive, which is not included. So it is only 20 and 40. And similarly, this one, it shows in Python, it demonstrates that there is no index out of bound exception, and it also starts from 2, that is 30, and in step of 1, because step is not specified, end is 10. So the 10th index is not there. So it was supposed to have crashed in C#, but it doesn't crash. So it straight away goes to 30, 40, and 50 because there is a step of 1. So 30 after that, 40, then 50. So all the elements after 30 inclusive are covered. Okay, this I have already covered. So works on strings distant to tuples. If name is a string, Python, print name from start is P because it is not specified, and this is up to start, stop, and step. So stop is at 3 PYT. It prints out PYT. Okay, and no index out of the bound errors because which I have just told, it doesn't crash. Now here again, if you have a closer look, why pyt, it starts from the index 0, that is the first place, and then second, and then third, and this is actually index 3, that should be h, but h is exclusive, so h is not printed, so only pyt are printed. And why it is compact? C# equivalent is more verbose, like variable numbers is new list of integer 10, 20, 30, 40, 50, and result is nums.getRange 1 to 3. And in Python version is simple and elegant, nums just 1 to 4. Okay, so start is 1, stop it at 4. So this is inclusive, this element is exclusive, and it is simple and elegant. How Python interprets steps in slicing, that's also I have told. Print nums 1 to 4, interpreted at starting point is 20 because this is 1 at index 1, and stop is 4, exclusive, and step 1 is default. So it starts at 20, 20, 30, step is 1, then 40, and then 50 is exclusive. So this is not printed out, so 20, 30, 40. All right. And what if you add a step? Nums 1, 4, 2, starting point is 20, 1 at 20, stop is 4, step is to 20 and 40. Default step is 1 unless specified. Negative step means reverse direction. Right. And then error handling. Error handling in C# and Python are quite similar, except in here it is try catch exception, and here it is try and accept exception as E. And this is no catch, it is except. And then of course finally, and instead of throw new, we raise exception with the raise, raise exception error. Here it is throw new exception error. Okay. Python also encourages checking for none and raising exceptions explicitly, which matches the intent of throwing if null in C#. So if argument is none here, so it raises value error, argument is none. Now there is some object-oriented syntax. Python is also object-oriented, but lighter on ceremony. There are no public private keywords by default. The constructor is always named underscore init underscore. This is actually, I have already taken double underscore. Dunder, init, dunder, and self must be the first argument in all instance methods. So self.age, properties are just variables prefixed with self. This is a public property in C#, where it is in Python written as self.age. Okay. Now the LINQ versus Python comprehensions. So you might love LINQ in C# and Python has something equally elegant, list comprehensions, which we have already learned actually in this loop section. A single line x into 2 for x in nums if x is greater than 0 replaces both filtering and projection, and is used everywhere in Python data science. So C# equivalent syntax is nums dot, where x goes to x greater than 0, dots after going through this condition, it selects x into 2, multiplies by x multiplies by 2. Okay, and it is much shortcut, easy to remember and implement. So in Python. Okay, so finally we come to namespaces and imports. While C# uses using to import namespaces, Python uses import. So import math, and then from math import square root. You can also import specific functions or classes using from module import name, giving you more flexibility. Python imports are lighter and easier to manage, especially in notebooks.